Good morning. Today, I welcome you all on behalf of Rasa International School to study Class 10th, Chapter number 10, Light, Reflection and Refractions. Part 3, it is on book page number 171 to 175. Today, in this, we will study today about refraction of light. In our earlier videos, we have discussed about reflection of light. In reflection, the light strike the surface, that is the reflecting surface, and come back in the same medium. But in refraction of light, the light will pass from one medium to another, and while passing from one medium to another, that medium should be which that medium should be transparent. Means it allows the passage of light through it, like glass, water, air. Okay, so they are the transparent medium which allow the light to pass through them. So here the question arises: if the light passes from one medium to another, how the light will follow the path, whether that path will be straight or it will be changed. So that is we discussed in this over here. Light seems to travel along a straight line path in the transparent medium. Okay, what happens when the light enters from one transparent medium to another transparent medium? Does it still move along the straight line path that we will discuss, or it changes its direction? क्या एक लाइट जब एक ट्रांसपेरेंट मीडियम से दूसरे ट्रांसपेरेंट मीडियम में जाती है तो क्या वो स्ट्रेट लाइन पाथ को ही फॉलो करती है या उसके अंदर कोई चेंज आता है? अगर आता है तो क्या चेंज आता है? ओके, सो वी शैल रिकॉल some of our day-to-day experience. Okay, you might have observed that the bottom of a tank or a pond containing water appears to be raised. ऐसा लगता है किसी टैंक में पानी अगर भरा हुआ है तो वो पानी ऐसा लगता है कि वो बॉटम उसका नीचे नहीं थोड़ा सा ऊपर है. Similarly, when a thick ग्लास स्लैब इज प्लेस्ड ओवर अ प्रिंटेड मटेरियल, जैसे कि हम देखते हैं कि हमारा जो ऑफिस टेबल होता है या हमारा स्टडी टेबल होता है उस पर जो एक थिक ग्लास स्लैब, एक कांच का जो स्लैब होता है, अगर उसके नीचे हम कोई पेपर रख देते हैं जो कि प्रिंटेड है तो उसमें क्या चेंज आ जाता है? द लेटर अपीयर्स टू बी रेज्ड व्हेन व्यूड थ्रू दी ग्लास स्लैब. जब उस ग्लास स्लैब से उस पेपर को देखते हैं तो उसके जो लेटर्स हैं उस पर जो लिखा है वो ऐसा लगता है कि वो ऊपर आ गया है. ओके, सो व्हाई डज इट हैपन? Have you seen a pencil? Okay. Have you seen a pencil partially immersed in water in a glass tumbler? आप एक ग्लास लीजिए, ओके, उसमें एक पेंसिल को इमर्स कर दीजिए, डुबा दीजिए, तो क्या होगा? इट अपीयर्स टू बी डिस्प्लेस्ड, ओके, एट द इंटरफेस ऑफ द एयर एंड वाटर. वो ऐसा लगेगा कि वो पेंसिल, सपोज ये ग्लास है, ओके, इसमें यहाँ तक पानी भरा हुआ है. अब हम एक पेंसिल ले लेते हैं. क्लियर? 1 minute. So we have considered a pencil. This is a pencil. It will be bent. Okay, it will not be appear straight, it will be bent. Why it bent? Why it bent? Because of the atmospheric refraction. Now let us see what is that. Okay, so it appears to be displaced at the interface of air and water. You might observe that a lemon kept in the water is in the glass tumbler appears to be bigger. अगर हम लेमन को पानी के अंदर इंसर्ट करके रखें तो वो ऐसा लगता है वो बड़े हैं. क्यों? ओके, फ्रॉम देयर एक्चुअल साइज when viewed from the sides. Okay, so we will discuss these facts with the help of the ray diagram of the glass slab. Okay, so let's start with that. So refraction through a glass slab, first of all we will discuss this. Okay, so here we have a glass slab ABCD, A, B, C and D. Okay, now in this glass slab, this is our incident ray. Okay, this is our incident ray coming from air, that is written over here also, air, and here it is entering the glass and again it is coming back to the air. So the light ray which is coming from the air and enters the glass, we should remember that we first draw the normal to the point where the incident ray is striking the surface of the glass slab, that is the interface of the two media. interface of the two media, that is air and glass. Now at this normal, when this light ray incident, there is an angle of incidence over here, that is II or I1. Okay, when this light ray and strike over here, it will passes from one medium to another, that is from the air to the glass, and this light ray will should go straight. But what happen actually is, when the light ray enters from the rarer medium to the denser medium, rarer means whose density is less as compared to the other medium. Now air is less denser than the glass, so when a light enters from the rarer medium to the denser medium, जब एक लाइट रेयरर मीडियम से कम डेंसिटी वाले मीडियम से ज़्यादा डेंसिटी वाले मीडियम में जाती है, तो लाइट जो होती है नॉर्मल की तरफ बेंट हो जाती है. So instead of following the path, the straight path, it bends towards the normal. वो bends की तरफ shift हो जाएगी. किसकी तरफ bend हो जाएगी? Normal की तरफ shift हो जाएगी. Okay. So this is your angle of refraction. Now we have studied angle of reflection, when the light come back in the same medium after reflecting from the reflecting surface. Now it is entering from one medium to another, so it is, this angle is known as angle of refraction. Now this light which has been passing through the glass will strike the other surface of the glass slab. There we also draw a normal. Okay, there we also draw a normal. Okay, and at that what we will see, now it entering from the denser medium to rarer medium. Why? Now it is entering from the glass to the air. Now it bends away from the normal. It bends away from the normal. Instead of going in this path, it will move away from the normal. Instead of going in this path, it move away from the normal. Now here, this angle is known as angle of emergence. Which angle? This angle is known as angle of emergence. Okay, angle of emergence. Now you should remember this, that when the light passes from the rarer medium to the denser medium, it bends towards the normal, and when light passes from the denser to rarer medium, it bends away from the normal. This refraction of light is the phenomena which is responsible for all those activities or all those things which we have discussed, that when the lemons are being kept in the glass filled with water, when they are being looking from outside, they appears to be big. The bend, okay, the bending of the pencil at the water and air interface, clear? So these are the things, the rising of the letters, or the letters appears to be raised up when they have been placed, the written paper is being placed under the glass slab. Okay, so these are the things which have been responsible, that responsibility is because of the atmospheric refraction as well as refraction of light through the where, through the one medium to another. Is it okay? Now further we will discuss about the laws of refraction. We have discussed about the laws of reflection earlier, that the incident ray, the normal ray and the reflected ray all lie in the same plane. Second, we have discussed the angle of incidence is equal to the angle of reflection. Now here we are discussing about refraction. So here the incident ray, the refracted ray, okay, not reflected, it is refracted ray, and the normal to the interface of the two transparent medium at the point of incident all lie in the same plane. सारे ही एक ही plane में होते हैं. Okay. The ratio of the sine of the angle of incidence to the sine of the angle of refraction. The ratio of the sine of the angle of incidence to the sine of the angle of refraction is constant, and that constant is known as refractive index. That constant is known as refractive index, and this law is known as Snell's law. Okay. Now what is refractive index? Okay. So we have discussed that it is sine of the angle of incidence to the sine of the angle of refraction. Now it is represented by mu sine. Okay, it is either been written as sine of the angle of incidence to the sine of the angle of refraction, or velocity of light in air to velocity of light in particular medium. So if it is been refractive index of particular medium, its correspondence to air, then it is known as absolute refractive index. जब भी किसी मीडियम का रिफ्रैक्टिव इंडेक्स एयर के कंपैरिजन में बात की जाती है तो उसको आप क्या बोल सकते हैं? absolute refractive index. Is it okay? Good. So now refractive index is the index, okay, can be linked to an important physical quantity, the relative speed of propagation of light. रिफ्रैक्टिव इंडेक्स को हम लिंक कर सकते हैं किससे? कि उस मीडियम में लाइट की स्पीड क्या होगी, लाइट की स्पीड उस मीडियम में चलने की क्या होगी. इट टर्न्स आउट दैट द लाइट प्रोपेगेट विद डिफरेंट स्पीड इन डिफरेंट मीडियम. लाइट जो है हर एक मीडियम में अलग अलग स्पीड से चलती है. ओके, लाइट ट्रेवल्स फास्टेस्ट इन वैक्यूम और एयर. ओके, with the highest speed of 3 into 10 to the power 8 meter per second. 3 into 10 to the power 8 meter per second. In air, the speed of light is only marginally less as compared to that of vacuum. So in this entire chapter, we will discuss that in the speed of light in air and vacuum is 3 into 10 to the power 8. Is it okay? The value of refractive index for a given pair of media depends upon the speed of light in the two media. That I told you, that refractive index of the medium with comparison to the air is equal to speed of light in air to the speed of light of in that medium. Is it okay? Now, so that we have discussed that the speed of light in medium 1 to the medium 2. If we write refractive index of the medium 2 in comparison to medium 1, then what we'll say, the speed of light in medium 1 to the speed of light in medium 2. That is been written over here. Is it clear? If we write refractive index of the medium in comparison to medium 2 of medium 1, then we write speed of light in medium 2 to the speed of light of medium 1. Is it clear to everyone? Okay, so the light entering from the medium 1 to the medium 2, clear? Then the refractive index of medium 2 will be written in this way, and the refractive index of medium 1 will be written in this way. Okay, here the speed of light is v1 and here the speed of light is v2. Is it clear to everyone? Good. Now that is also written over here, this refractive index of a medium, in comparison to air is equal to the speed of light in air to the speed of light in medium. Okay, by dividing these we are able to get the refractive index value, which is of the form, for water it is 1.33, for the glass it is 1.52. Okay, some refractive index of some mediums have been provided over here. Air 1.0003, ice 1.31, water 1.33. In same way, the refractive index of different medium have been provided, and the diamond is the most one, that is 2.42. In this means the speed of light in the diamond is the least in comparison to all these medium. Is it okay? You don't have to learn the values of these. Okay, it will be provided in numericals as well as in boards exam. Okay, you have to do these numericals. I will tell you, I will send you this sheet, okay, of solved numericals. Work on them. If you have a doubt, okay, we will discuss in class. Thank you. Have a nice day.